70% of the Earth's surface is covered by water, but just 1% is fresh water can be used to remain the survival of more than 7 billion people. Without fresh water, human beings will no longer be exist. Unfortunately, declining water quality has become a global issue of concern nowadays. Inland water bodies are suffering a phenomenon of an eutrophication. Eutrophication happens when a large amount of untreated wastewater containing physical, chemical, and biological pollutants from human daily activities, industrial and agricultural activities flowing to a water body in a long time. The water color of an eutrophic lake will turn into green color because chlorophyll pigments are floating on water surface. Chlorophyll strongly reflect the green light, so that is the reason why you see the green water in an eutrophic lake. Regularly quantifying the chlorophyll is an efficient way to monitor the water quality and avoid the phenomenon of eutrophication. In this study, we use satellite remote sensing technology and deep learning technique to create the spatial distribution of the chlorophyll concentration for one of the most important but also very polluted lake in the Philippines, Laguna Lake. So what is remote sensing and how remote sensing become very useful in water quality research? Remote sensing is a technology being used to collect spectral information of every object on the Earth's surface from long distance by using an optical satellite. One remote sensing image can receive the spectral information of 180 km by 180 km area in multiple spectral bands. In water quality research, by using satellite remote sensing image, we can receive spectral information of every area in a large water body. In next step, this image would be further processed by a convolutional neural network, the most powerful deep learning architecture in processing image. A convolutional neural network, or CNN, is a class of machine learning consisting of four important components: the convolutional layer, pooling layer, activation function, and fully connected layer. In my study, we developed a CNN architecture called WaterNet. The training data and the validation data to the WaterNet is a concentration of chlorophyll that we have taken during several campaigns in Laguna Lake, Philippines. The input to the WaterNet is a small area with size of 7 pixels by 7 pixels on satellite image. The center pixel is the location we take the water sample. CNN will learn the spatial and the spectral patterns of the input image with high or low chlorophyll by using many kernel filters to scan the input image in vertical and horizontal directions to automatically identify the important feature of the input image. That is a non-linear learning process. The difference in my study are WaterNet make use of two-stage training instead of one-time training in other CNN architecture. WaterNet use less sample for training but produce higher accuracy in prediction than other machine learning models and remote sensing algorithms in chlorophyll estimation. Conducting this research, we would like to provide the spatial and temporal distribution of chlorophyll in the most important but very polluted lake in the Philippines. I believe that the chlorophyll map will be very useful document to the government and the environmentalists, showing them the water quality condition of Laguna Lake. The government can take action if necessary in order to guarantee a healthy aquatic environment for inhabitants and socio-economical developments